Let's do it. Let's talk about wire speed settings for short circuit MIG welding.
This welder welds with both 115 volt and 230 volt. We've got it plugged into the wall on 115 volt today. We're going to start off using the recommended settings on the chart that's inside of the welder. 18 volts, 236 inches a minute, using 035 ER70S6 wire and C25 gas. That's 7525 argon CO2. Going pretty good. The settings are pretty accurate on that chart, as they often are these days. They're a good starting point. So what we're going to do is we're going to gradually decrease the wire feed speed until we can tell a big difference. So I went down to 200, still at 18 volts, 200 inches a minute here. Not a whole lot of difference. Arc is still smooth. It looks very much similar to the first speed. Just subtle difference. It widened out a little bit, maybe wet in a little bit, less crowned up, but very similar. Now let's go down to 173 inches a minute. And this kind of demonstrates that sure, there are optimum settings and there are recommended settings on the chart, but there's also a lot of leeway, a lot of forgiveness when it comes to wire feed speed. What you have to remember though is wire feed speed does control your amperage and heat input. It also controls how much metal is deposited, and it can kind of affect your travel speed because higher wire feed speeds kind of make you want to go faster. Let's drop it down now to 126 inches a minute and see what this looks like. At this low wire feed speed, we hear kind of a rattle in the arc. It's not that smooth bacon sizzling sound, it's more of a rattle, and it's a cold bead. And it's causing me to slow down, to use a really slow travel speed.
One 126 inches a minute, that's almost half the wire feed speed. And what you don't want to do, what you never want to do as a welder is turn something down just to make it pretty, just to make it look good. You want to make a strong weld, even at the expense of appearance, if you have to. But you want to make a strong weld above all. Pretty welds are no good if they break.
Let's drop it down even further to 102 inches a minute. We're going to hear a definite difference in the arc sound here. Much more of a rattle, just a puttering along. It's really slowing me down. This is taking quite a bit longer than the other beads did. And yet, when I'm finished with this bead, it doesn't look all that different from the rest of the beads, which is kind of amazing actually. So now we're going to drop it down to incredibly low wire feed speed of 82 inches a minute here. And we're going to notice a distinct difference here. This is where we really notice a difference. Like this is completely out of control. The wire is almost wanting to melt back and run up into the contact tip. And it's hard to keep the bead going. It's hard to keep the arc going. But it's welding. I mean, it's running a bead, I should say.
I was really surprised I could even keep that bead going. I had to go ultra slow. I had to keep my stick out even, or I was just going to lose the bead, or it was going to burn back up into the contact tip. That's an extreme. Let's go way high on the wire feed speed now and see what happens.
275 inches a minute is about max when plugged into the 115 volt. Some machines are wired with a very narrow sweet spot and they just won't weld very well outside of that sweet spot. This isn't one of them. This is doing really well even at this really higher wire feed speed. Kind of amazing that it did that well, but it did. There are probably applications where you could get by with that high of a wire feed speed with 18 volts. I lowered the voltage here to 14.9, thinking I would get wire stubbing in an erratic arc, but it was still smooth. I had to lower the voltage all the way down to 14 volts.
Now I'm running this little welder off of 115 volt today. I'm doing a little series on 115 volt welding. I want to really put it through its paces and see what it does. So I'm limited on how much wire feed speed I can even go plugged into the wall on 115. So I dropped the voltage down all the way to 14. So the voltage was down to as low as it'll go, and the wire feed was almost as high as it would go. And that's what it took to get this.
This is what it looks like when you have excessive wire feed speed, stubbing in the puddle. Again, I found it kind of interesting that I had to go to extremes to get a bad arc. All right, here's the bottom line here when it comes to wire feed speeds. This is what it sounds and looks like when you don't have enough. And this is what it sounds and looks like when you have too much wire feed speed. But let's end on a good note. I took some 11 gauge cold rolled steel and I used the settings, the recommended settings on the chart. We're going to run a simple little fillet weld, 18 volts, 236 inches a minute. Simple fillet weld, 11 gauge cold rolled steel, 18 volts, 236 inches a minute. Sounds just a little bit like bacon frying, doesn't it? That means that someone put some effort into making that MIG settings chart, because it's dead nuts. I think we saw in this video there's quite a big range, but this MIG chart is really close.
Short circuit MIG is a good process, but you gotta set it hot enough. You can't monkey with the settings just to get a cold, pretty bead.
Hey, if you're interested in this welder, I listed it on my store at weldmonger.com. And did you know that it also comes with a spool gun and everything pictured here?